Hello, and welcome to today's video lecture. Today, I want to show you how to access all of the data that has been collected by the Lovotex network. One thing that I didn't mention when I was talking about the Lovotex network is that each person who is responsible for managing a set of Lovotex sensors has to go out and collect the data throughout the year. We do this by downloading the data from the sensor in the field to a temporary data storage device, and then we bring it back to the lab and upload it onto the online data site. When we do this, the folks at Plymouth State University run quality control and quality assurance on the data and then post it all on a public Google Drive so that anyone can have access to it. The first thing you will have to do as part of this data usage video is to go to the 4 Weeks on Water curriculum website and download R. Here I am on the 4 Weeks on Water curriculum website under Course Materials and Videos. If you scroll down to the section entitled Data-Related Links and Handouts, you can see that there's a Downloading R for Mac document, and there's a R Downloading Worksheet for Windows document. Please follow the directions in one or the other of these documents depending on the type of computer that you're using. And then come back to this video to see where we access the data for you to use in R. Now that you've downloaded R, you need to navigate back to the 4 Weeks on Water website in order to access the Lovotex public data drive. Here I am under Course Materials and Videos, and if you scroll down to the data-related links and handouts, and there's a link for the Lovotex public data drive. While that's loading, I'm going to go back to the 4 Weeks on Water website. I just want to remind you about that document entitled Lovotex Sensor Sites and Descriptions, because you're going to need that in order to figure out the 3-digit codes that you want to access for particular sites on the Lovotex public data site. Once you know which data you want to download, it's a fairly easy process. For example, if I want to download the data from the Androscoggin River lower one, which I know the code is ARD, I'm going to click on it. And usually what happens, because it tries to preview it and it can't, is this window pops up. It says, it can't preview this document, and it's going to give you the option to download it anyways. So click the download button. And then you can see down here in the left-hand portion of my window that it downloaded. So I'm going to click on that. And it's going to open that up in Excel or some other spreadsheet managing software that you have on your computer. And you can see that this data sheet looks a lot like the data sheet that we downloaded from the Data Discovery Center. It has a site column, it has a timestamp column, which if we make that bigger, TS stands for timestamp, and this is actually in Unix time, so it's not a time frame that we recognize, but you want to leave that as it is. We can see here that there is temperature in degrees centigrade, we have the specific conductance in microsiemens per centimeter, and we have the stage in centimeters. Once your data is downloaded, you can actually tell it to save. And you'll see up at the top it's already as a CSV file. I'm going to save it on my desktop. Once you've saved the CSV files from the Lovotex public data site that you want to process, you need to go back to the 4 Weeks on Water curriculum website. Again, scroll down to the data-related links and handouts section, and you want to look for the file that says R code for sensor curriculum. You're going to want to click download. Once your computer downloads it, I'm using Google Chrome so it shows up in the bottom left. I'm actually going to go to my folders, go to downloads. You can see that that document has been downloaded right here. And I'm actually going to move that to the same place where I put my ARD file. I'm going to move that to a folder that I've created on my desktop. And then once you've downloaded that R code, you want to navigate to your R software and open it. And when you open it, it's going to look something like this, and you can see it says 64-bit up here. So you have to make sure that you open the correct one based on your computer system. If you need to figure out what your computer system is, you can go to Start, go to Control Panel. You have to find where it says system here, click on it, and you can actually see it says system type. My system type is a 64-bit operating system, so I want to make sure that I'm running the 64-bit R software. If yours says 32-bit, make sure you run the 32-bit software. Once you have the R software open, you're going to go to this little hot button here, Open Script. You can also go to File and Open Script. And then you want to navigate to the area where you saved that R script that you just downloaded. So for me, that's the desktop. That's in this folder. I'm going to double click on that R script. And you can see that another window pops up. I'm actually just going to put it over here on the right-hand side of my R screen. And just so you know, R is a coding software. And so any little bit of code that's written that the first part of the line has a number symbol in it, the R software will ignore. So you can actually see at the top of this bit of code, I've given you a little bit of guidance as to what this code will do. The first two things I want to point out here are the site, the date area, and actually there's a third thing, the folder. Those are the things that you're going to have to change based on what you want the software to process. So first of all, you might notice there's a 3-digit code here. That's referring specifically to the sites that you've downloaded that you want to compare, say, from the Lovotex public data site. This represents the second college grant up north of Errol, New Hampshire. I'm going to have to change those because I'm not using that data in this particular example. But you can see that we have the month, day, and year here for both the beginning and an end, so you can define the time frame that you want to look at the data or have the data analyzed in. And then the third thing is the folder. We have to look specifically at where the data is located, and then you have to tell R where that data is located. I'm going to show you how to do that. Okay, so what you have to do now is navigate back to where you put your Lovotex data files. And for me, that is on my desktop in a folder that I've named that. And you can see here that I've actually downloaded 2 Lovotex data files. I showed you how I downloaded the ARD file, and I went back and I downloaded the second ARU file representing the upper sensor in that water body. And what you want to do in order to find out exactly where these files are located is you can right click on one of them, and if they're both in the same place, then you only have to do this once. But you right click, go down to Properties, and then you can see right here in the middle of this pop-up window is the location. You actually want to highlight that, copy it. I'm going to press Control-C to copy it. I can close that, minimize that. I'm back in my R software window again. So I'm actually going to paste that location into the folder section of this script. So I'm going to highlight what's there. I don't want to highlight the quotation marks. Those have to stay. I'm going to highlight what's there. I'm going to paste that, and I use Control-V in order to paste that. And then the last thing you have to do before you move on from the folder location is you have to go through and add a second slash in between each one of these folders. You have to do that, and that's a weird coding thing that's required. Okay, now I've told R where the data is located that I want it to process. And now I have to tell it what it's called. So I'm going to go back up here to the site area, and the 2 files that I'm looking at are ARU and ARD. Again, I want to make sure I keep those quotation marks. Okay, you can't delete those, otherwise it'll have an error. And now I have to tell it when I want to have the data analyzed, or the time frame in which I want it to analyze data. And I'm going to choose to look at basically the winter of 2013 to 2014. So I'm going to go from December 1st, 2013 to March 31st, 2014. So I've told R where the data is located that I want it to process. I've told it what the data names are, okay, based on that 3-letter Lovotex code, and I've given it a time frame in which to give me feedback for. And now before R can process the code, you have to tell it which code it's going to process. And you do that by highlighting from the site. You don't want to include any of this stuff because this is just guidance for you. You want to highlight from the site. Just highlight all the way down. through the rest of the code. And the rest of this code you don't have to worry about. It's something that we've pre-written for you so that it will spit out certain information. Once I have it all highlighted, I'm going to go back up to this little hot button area, and I'm going to choose the third button in, and it's the one that says run line or selection. So I've told it the selection, and now I'm going to tell it to run. I'm going to click that, and you can see my R console window here on the left is doing some processing. And now it's done. So first of all, I like the R console window. If I scroll up, it's going to give me some information that I told it to give me. Okay, so this first section is it's going to give me a maximum, a minimum, and an average temperature for that first site. And that first site I told it was ARU, I believe. And if I've forgotten, I can go back here, scroll back up in my code, and say, yep, site 1 was the ARU. That was the upper site on the Androscoggin. And it's telling me for the winter 2013-2014 that the maximum temperature was 0.44 degrees centigrade, the minimum was 0.07, and this was the average daily temperature. And it has the same for specific conductance. That SPC stands for specific conductance. That has to do with electrical conductivity. If I scroll down, it's telling me the average stage. Remember, this is in centimeters, okay? So the depth of the water in centimeters at that location. Tells me the max was 171, minimum was 96.9, and the mean was just over 136. And it gives me all of that same information for site 2. Temperature, max, minimum, and mean, specific conductance, max, minimum, and mean, and stage, maximum, minimum, and mean. Okay, so this is exactly what I told it to tell me. And to go back to it also produced a graph. I'm going to make this bigger so that we can actually look at it. So you can see in this upper left-hand area, it's telling me that the black line represents ARU and the red line represents ARD. And so we can actually look at what these two different sites look like over the course of the time frame that I told it to analyze. So we have specific conductance in the middle, stage up top, and water temperature down at the bottom. And this is another situation where you can actually use these figures that R produces for your website that you have to produce for the 4 weeks on water curriculum. Now, I want to give you 2 troubleshooting scenarios when using this R software. The first has to do with the folder, that location where you told R to look for your data. If you don't go back through and put in those extra slashes, say I accidentally only put that first extra slash in, what you can do before you even run the whole code is you can place your cursor at the end of the folder part of the code and go back to that run button and click it. Click it, you can see that it ran the code a little bit and it's giving me an error. So that's telling me right off the bat that there's something wrong with the location that I told R to look for the software. And in this case, it's because I didn't put those other slashes in. If I put them both in, put my cursor at the end of that line of the code, go back to run, you can see it tells me that it checked the folder and it did not give me an error symbol, which means that it can get to that folder and it's accessing that folder just fine. The other troubleshooting scenario I want to give you is that for some of the time frames that you tell R to go looking for in the data might give you results that aren't what you're expecting. Okay. You can see that I've changed my date range from the 1st of March 2013 to the last of July 2013. And I'm going to run my code again. So I'm going to select it all, right down to the very last bit, and click Run. It takes a second, works through that code. And right off the bat, you can see number 1 over on the right, what it tells me it found for data. First of all, it doesn't have 3 different graphs this time, it only has 2. So it's looking at water temp, specific conductivity, and you can see that there's nothing for stage. For some reason, if I look over here on the left of my console window, it wasn't able to get to the data in stage. The stage here, in the stage column of that file. And you can see it's both for site 1 and for site 2. Also, in the temperature and specific conductivity sections, both for site 2, if I scroll up, you can see this for site 1 as well. You can see that our minimum specific conductance for the sites is -9999. And you might recall when we were looking at the CSV files in Excel, I told you that when one of the cells in that file has a -9999, it means that the data was not collected on that day or during that time frame for some reason. And so you can see that R tells us the maximum, say temperature, was 25.86 for that location. It has a maximum specific conductivity for that location at 54.2. But you can see that the minimum for both of these is -9999. And because that minimum is an incorrect data point, or in this case, it's a number that represents that data was not collected, it throws off the mean as well. So you wouldn't be able to use the mean for those two parameters that are being measured at that site. And you can see that there's these two big patches in each of the graphs where data was not collected.